Good afternoon. My name's Glenn Smethurst. I'm a product manager at GE and I'm responsible for the technology layer, which is Small World GIS. What I want to talk about in this session is what are the features, the capabilities you need from GIS to allow it to scale and serve your organization rather than disrupt it, in essence. So let's have a look at some of the foundations of utility GIS. So in 2020, if you didn't have GIS, I'd expect you to go and look at the vendors and see what their GIS attuned to network GIS models. I don't think there are that many that do complete network GIS models. But if you typically, a lot of you will be running GIS to certain degrees with that network model for 20 or 30 years. And what I want to talk about are what are some of the drivers and the capabilities that you might need for your GIS to support you in the future. And then the final really important point, and really is a message through the whole talk really, is that even with that, you're going to evolve. You can't buy a model that's going to be future-proof for all the needs that you might come across. So a lot of the work that we do is how we evolve our products. So I'm thinking of evolution of our GIS with what customers are doing and adding to that and meshing them together. So a lot of the work that we do is in deployments with customers is to make sure that there is a proper framework for that evolution of the database and upgrades. So an example I have from talking to a customer just the other day is that they were taking our portfolio every quarter. We release our software 4 times a year, and they were embedding a number of additions to that, which are specific to their environment, to the tune of 4,000 data model upgrades, quite small little database changes over a period. So where you are now and where you need to be at the end of this year won't be where you would need to be in the future. The way that I think of GIS is this evolving platform and engine for the network processes that you have in your utility, and you need to plan for that to change. So one of the models I talk about and we use a lot at GE is an asset management lifecycle. So in the center of there, we have GIS, a network GIS that represents your as built or your normal state of your network. It will interface potentially, depends on what you need, with other systems like ADMS, which will hold, the current switch state, the current state of the network as best as we know. But the foundations of how that information flows, it comes from that sort of spatial network model that we get from GIS. So as you look around this asset life cycle, you will see things in a plan. So how do I plan new connection requests? Increasingly, those are going to use new types of equipment for distributed energy resources. How do I want to automate some of our planning? So a certain amount of the tools that GIS vendors are looking at is how can I take from knowing that I want to serve some customers, how do I automate some of that planning and then as human approvals? And even more so, what is the decision support that we need? Should I be building afresh, replacing the network here, or should I be upgrading? Go around the life cycle, design phases. What's the detailed design that you need in GIS, which will ultimately give the instructions that people need to go and build out in the field. But intrinsic to that is the business rules and data quality that you need to maintain in your GIS so you can have some follow-on processes and also share key bits of information like costing with your enterprise asset management, SAP or maximise or whatever you're using. Going to the build phase, here we've got people actually extending the network and recording it. Increasingly, that's gone from sort of red line sketches to red line and attribute updates, or black lining in some regions they call that. And really now we're at the point there's some intelligent network capture. So the devices that people have actually have an extension of that system of record available to them so they can capture that information and bring it back ingest in the GIS. So that's a big area of improvement, actually. The operate stage, so if you're doing that integration with ADMS, your models and the views that you can have in GIS, you need to be able to pass them over to ADMS in the way that they can do their switching, planning, and control. So here we're talking about the complexity or the needs to have sort of a correct circuit model, which is what they need to operate, but also the types of diagrams that they need. So they don't always use a regular map geospatial one. They often are expressing to their users single line diagrams and network schematics. So you need to be able to house those and update them in concert with ADMS. And as we look at the maintain phase, you've got the traditional inspect and collection, but again, reaching out to the asset management and analytics tools, which allow you to figure out where you need to prioritize your maintenance. So what are the drivers for this? So the utility space is, like a lot of industries, is changing ever more rapidly. So in particular, what's happening with DER technology and the expansion in the network. So as over time, more and more of the network is going to have distributed energy resources in. Applied to that, changing regulatory reform, so that's always a driver. But an particularly interesting one is the workforce transformation. Is the types of people that are in your organization are different to the people that you had 30 years ago, and the tools they expect to use and the capabilities those tools have, through web and mobile, they can access information on many sorts of devices, online or offline, and they expect different sort of user experiences than perhaps workstation GIS. And there is some drivers on the technology front, which are fairly important, and they can apply correctly, help you keep pace with sort of utilities technology. And that means some transformations to these sort of agile and DevOps sort of techniques. So I'll talk a little bit about utility GIS in operation and what we're seeing with customers there. There's quite a technical piece in some ways called cloud native technology, but bear with me because that actually has some practical steps in helping you meeting demand and then moving on to some of these ideas of this philosophy called DevOps. So cloud native, and this is technical, is actually a very precise term, and it means you're packaging and deploying your software using some industry standard technologies. So containers, Docker is the leader of sort of containerization technology, and Kubernetes, which is a way of orchestrating those containers in there. Excuse me. So despite the name, it doesn't necessarily take those technologies and then you have to run it on the cloud. In actual fact, a lot of people are exploring putting it on premise, indeed on the cloud, and there's certainly some benefits to putting it on Amazon, Azure, or whatever, but also these hybrid deployments where you have some portion of it on premise and some of it on the cloud. Cloud technology has changed a lot people's conception of cybersecurity and what that means to business sustainability. I think a decade ago there was still a lot of concerns about it, and there still are some regulatory concerns about where your data needs to reside globally. But it's become the mainstream technology, and that's where a lot of the best practices around security are now from. And this common technology now allows you to monitor and maintain your ease of your GIS deployment in a much more industry standard way than you would have done from sort of vendor proprietary approaches, going back sort of 10 years ago. And this isn't just GIS. This is actually coming from other parts of the business, and GIS is sort of falling in line with that. And it means that the software that we provide as vendors is taking this much more modular, secure, scalable approach, and you'll hear the term microservices. So why is this scalable? What's this different to what I have now in my server environments with lots of server racks? So I'll try and show you in a sort of animation of a slide. So if you think of a sort of initial deployment, and on the left-hand side here, you've got some workstations, some desktop workstations, and they're going to be running in the cloud, but you're going to access them on workstations. So you'll use some bits of technology, virtual desktop infrastructure products, and there's one called Citrix Palette. So that allows you to run your workstation software on the cloud, but you can access it wherever you need to. And on the right hand side is with the is a cluster. It's called a cluster, and you can see the ship steering wheel. That's the Kubernetes logo, and inside that cluster are a number of running bits of software, which are called in pods in the Kubernetes terminology. And that environment will give you entirely, you can run this entirely on the cloud, on Amazon or whatever, and that will give you those desktop environments as your initial deployment. So you can establish your data model, your business rules, and the things that you need. So this is becoming a common deployment. But it's not static. It's not like a fixed set of servers in your server room. As you progress, you would like to make those web users have their system, so there'll be a web go live, and you may want to integrate with your ADMS. So you want to stand up those integration points. So what we've done is, in this diagram, I've enlarged the cluster, which is actually just a dynamic configuration, especially if you're running it on a hosted environment like Amazon or Azure. So that gives you more capacity to run more things. And as those software, people start using the web applications, and some as the flow between jobs happening between ADMS happen, then more services instantiate themselves automatically inside this cluster. As you expand again, so maybe you've got a mobile go live, and you've got a lot of disconnected mobile clients which need offline extracts. They need a model to be given to them, and you need to prepare them from the GIS. Again, gone through a dynamic deployment, you can say, my cluster is now going to be bigger, and I can add more service providers as those pieces of work start to happen. You start feeding those mobile devices. So the advantage of this is that you can scale out, and if you run this on the cloud platform, this is like sort of administration, just using your Amazon or Azure workbenches, that you can add these resources to it. But the really important thing is that it can shrink and adapt as the demand requires. So most utilities, their IT solutions, they will go down, the amount of use that happens at the weekend, or it may be a specific event that you need to scale up for a storm issue, or resolution or something like that. So one of the key capabilities this provides, apart from the security and some resilience, is this ability to expand and contract the work that your GIS is needing to. Adding more capabilities is just adding more pods and running software to one of these elastic environments. So it's quite an important change to the way that IT allows us to run our systems with very minimal disruption. So this DevOps approach, which is really a philosophy, it's not a brand name of a product or anything like that, is really taking this increased change of software environments from potentially many vendors, and how do I get the value that those new versions have and their responses to things like cybersecurity. So we all know that we need to keep our software up to date against the latest threats. How do we bring them into our environments in a much more iterative way, so we can design and deploy solutions together? So I've been working with some our customers, and G's been working with some of our customers who are taking this approach of really a partnership between vendor and customer, where they can take builds of our software even before we've released them to market if necessary, but certainly the quarterly release rhythm, and introduce them into their environment. So this is really a change of philosophy that is becoming prevalent in our environment, and it allows for business continuity. The final piece I just want to quickly mention in the short time I've left is how analytics are becoming important to GIS. We've introduced some new products in this space, but they become a natural partner to this, and a lot of it is again via cloud technology. The benefits of this, so cloud capability allows you to ingest a lot of data, LiDAR and photogrammetry style data, put it into a cloud environment and do some AI learned machine learning techniques across those. And the goal would be, apart from resolving some of the business challenges about vegetation and asset inspection programs, to improve your GIS network model. So we've been working extensively with some customers of this, and one North American one, for instance, found as a side effect of applying those analytics that they had a correction to 30% of their structures modeled in the GIS to feedback from that analytics platform. They're either location was wrong or poles and distribution network was absent from the GIS. So this is another example. Vegetation management and asset inventory are two areas that we're applying analytics, which become a natural partner for GIS. So very rapid recap. We covered a lot of ground there, but you can anticipate your needs for GIS. You can see the patterns that are available in the industry, and certainly if you go to the vendors such as GE, you will see things like I've talked about today. You have new options on how you operate and scale GIS, which will affect how you can treat it as a service for your business continuity. And increasingly, automation through applied machine learning is becoming a practical partner to the data that you have in the GIS and keeping it accurate. Okay, thank you very much. Look forward to any questions you might have.